So once again, welcome everyone. For today's is a very first session, and let's not be in a hurry in looking into what is this SQL Server, how it looks like, how to install it, what are the steps to be followed, and where this software is available, what is the hardware requirement, what is the configuration I need to be, how much space I need in my system. Let's discuss. Put all these questions later because first I want to understand the background history. So in this today's session, we'll try to answer few questions which will be always bothering whatever the technology you're trying to learn. So I have a lot of questions. Before I learn anything, I'll try to answer them to myself so that I can move on learning the technology. All right. So this SQL is designed to provide you with all the essential knowledge here, completely essential knowledge on the core concept, not only just core concept actually. We are going to see the syntax. We are going to see how the fundamentals of this language can be start and end so that you can never go wrong while designing your queries. So that it will definitely help you because as we are starting from the scratch, it will definitely help you to become expert and special in this domain. As I was keep saying, SQL, where it exactly this SQL plays a very important role. Whether when I'm working in a banking domain, where I'm working in a something called sales domain or something else, finance or web development, it works everywhere. It works everywhere. So if you want to become an expert in this, you need to have a strong basic concepts because going forward, if you want to be certified in this SQL server with SQL queries, you need to have a complete theoretical knowledge as well. So before jumping onto the details, let's get some valuable insights into the SQL that will help you in better understanding of this concept. Because first we need to start from the basics one. As mentioned in the demo, don't worry if you have never worked on the databases, it's absolutely fine. And that is what I need actually. As this session starts with completely from the basics and also the practical orientation. I never talk about only basics because we need to travel from the basics to advance, whatever the technology you learn, and we need to master it so that we can start practically implementing it, not only just for the knowledge sakes. So as you know, in the today's world, most of the organizations, not most, actually every organization, irrespective of their size of the employees, most of the organizations across the world are revolving around the data, right? So whether it's a small organization or if it's a very big Fortune 500 company, they always talk about the data because of the value that it adds to the business. And it's quite impossible for me or for anyone to answer the big business questions. If at all, if I want to answer somebody's business question, how many employees are there in the company? It's quite impossible for me, though it is a simple question, because of the massive data which I'm handling these days. Okay, massive data, massive amount of raw data you can say for now. There's a lot of things to talk about data. We'll talk about later, but let me start using that word, raw data. Okay, so whenever I want to answer some questions about the my data, which is a massive data which is coming across in my organization. If I'm working in a bank, obviously there are a lot of transactions happen every second, every minute, every hour. So all this information is sitting in somewhere in database. And if I want to know somebody's balance, or if I want to know how many transactions you have done over a period of a month, these are typically business questions, right? So when I want to answer, definitely I need to have such tool where I can quickly give an answer and create a report for you. But of course, I don't claim, I don't say that Excel is not fit. Yes, maybe Excel will support to some extent, and Access to, as we know, MS Access is also a database management system. But we need to remember that's a desktop application only. It's not server based. It's a desktop application. So we'll try to understand more about this word as well. What is a desktop application? How is a server based application works? What is the basic difference? We'll see that. But as I said, like Excel also works no matter because we've been from the ages we are using Excel, and Excel is a fantastic tool. Later on, I thought Excel is not getting sufficient because of its data size. If I remember correctly, 2003 version up to 2003 version Excel used to handle 65,000 rows. But later on, the advancement and the enhancement of the Excel from 2002, 2007 to 2019, the latest version has 10 lakh rows, right? 10 lakh rows. So that means it's a very good opportunity for me to store a lot of amount of data up to 10 lakhs of rows. But what happens, it is again, it's a kind of a desktop application. I cannot shareable. Okay, I cannot put it in one place and I can ask everybody to hit your questions so that it can give an answer. So it doesn't work. Even in the same case with the MS Access as well, it's a desktop application. So what I mean, I'm storing some information in database like MS Access, and whenever you want some answer from that, or you want to pull some report, or you want to extract some data required to current month or a current week or current day, obviously one person, two persons is enough, but multiple users cannot access the database because it is not server based. That's a limitation what we have to MS Access. And also what I've seen is MS Access can store up to 2 GB of data. That's it. That means if I'm working in a startup company or a mid-level of company, if I'm think I can survive with MS Access, no, it is not possible. It will work with a smaller level of projects, a smaller level of data information which you can store in MS Access, but not huge data. And if you think your data is flowing every day, it's highly impossible to use MS Access. That's a problem with the MS Access there. But according to the market research, if you just think about it, which I was speaking in the demo, uh, global data sphere, what they are saying is in 2008, we already reached 18 zettabytes of data. You can't even imagine what is zettabyte here. This is a total of data created, captured, and replicated in the. In fact, actually, what the future is getting predicted right now. The world's data will grow up to 175 zettabyte in 2025. We are in 2021, 2025. We may reach to 175 zettabytes. And as you know, we measure the data in terms of its size, right? So we know something called bytes, we know something called kilobyte, we know GB, nothing but gigabytes, and what else we have? Terabyte, okay, which is nothing but TB. Then we have something called PB. This is a petabyte. We have extrabyte, then zettabyte, then yottabytes. So these are nothing but. Don't worry if you don't not getting these terms. We know what is byte, right? We know KBs, we know MBs, we know GBs, we know TBs. Then we have a EB, then we have PB, then we have ZB, then we have YB. So these are all different measurements, how you calculate the data, the size. In fact, simply if I save some file on my desktop and I want to see the size, that's how you will try to find the size of any file or find the size of the data, right? How the data is being stored. And the very important thing, most of us, including everyone, the mankind always believes that the term data and information can be used interchangeably. I'm little confused here. We can use this data and information, these two buzzwords are very technical words, I can say. We can use interchangeably and means the same for us, right? So in general, when I'm speaking to someone, I have a data, I'll say I have the information about that guy, about the company. This is how you use in general language. But do I have a real difference between them? What is data and what is information? Okay, let's type in here. One is data, one is information. So whenever I talk about these two terms, as I said, like mankind been using these two terms like similar. Okay, even if you say information is same, even if you say data is same, there's no difference actually. That's what we believe in, but actually there is this difference. But actually there is a difference. Let's try to dig into more data, because irrespective of any technology you talk about, you always end up talking about a data finally, because as I said, many organizations are revolving about the data only, nothing else. If you want something to be make out some insights, you need the base information as your data. Just look at your mobile. If I ask, can you just pass me your friend's contact number, you'll start searching in your phone book. The reason is that's your database. And how you're searching, you're starting with, if you're finding a person name with starting with letter S, you'll type S so that you can just go to the list of S letters and start searching for that name. If you know the complete number, you'll dial the number. If you know the name, you'll type in the name. So this operations without any database knowledge, we are already been doing it. The only thing is now you want to do it on a computer with a specialized software. We'll see what is that specialized software mean. So data is in the real world, it is called as a entity or an object, right? So data is a, it's a piece of information. Again, I'm using this combination with the data and information. Let's see that. So it's a piece of information or a facts that need to be processed. It can be in any form actually. If you look at any text information, your SMS, your WhatsApp message, your Twitter, your Instagram, whatever the message you're typing or you're posting on a Facebook, it's all about data only, right? It's all about data only. It could be in any form. If I'm posting my picture, that's a data. If I'm posting some numbers, okay, any stock exchange numbers, what you see, or analysis, what you see, this is all it's a numbers. And sometimes you'll also post some measurements, okay. So when you see any data in the form of text or a number or the picture or the measurements, it's basically a data. Okay, let's see if I want to understand data, can I call this Monty as as a data? Yes, absolutely. Monty is a data for me. And where he stays in Hyderabad. Okay, and so Monty is the name of a person. That's what I can understand by looking at it. And Hyderabad is a place. It's a city place. Let me type something called 8. Okay, and I want to type something called 100. I lost. Now, so far I was able to understand this, but I lost now. I know Monty is a name, but at the same time, Monty can be a company name also. Monty name can be a female name, can be a male name. I don't know. It says Monty there. HYD I can understand because I have knowledge of this. What is city, what is country, I know. So Hyderabad is a name, a city name. 8 I don't know. Is it a date of birth or is studying in 8th class or it's a lucky number? I don't know. And again there is a 3-digit number 100. I don't know again what is that 100 mean. So data is always it is not a processed information. That's what I'm want to refer here. Data is always not a processed information. So Monty is not a processed information. Hyderabad is not a processed information. 8, literally, I don't know what is 8 means. 8, I know it's a digit. But what 8 means, is it a size? Is it your age? Is it something your employee ID number? I don't know anything about it. Until unless when it is processed, and if you give me as an output, then only as a layman or a business user, I can understand. For instance, the 100, absolutely, I have no clue what is that 100 mean here. So as I said, data is in the real world, it's considered as simply in the form of text, numbers, or objects or anything. Now let's try to focus something. What is information? When we talk about information, then you may totally agree with me that data and information cannot be interchangeably used. Now, as I said, Monty is a name, Hyderabad is a place. 8, I lost. What is that 8? Is it his age or its size, shoe number? 100, I have no clue actually. So let's talk about the information now. When data is processed, okay, whenever the data is processed or whenever it is organized in a such a way where anybody can interpret what is that given context, so that you are trying to give a real meaning there. So let's try to put the same thing again here. I want to say name. I'll say something called Monty here. Okay, makes sense for me now. Name, a person name is a Monty here. Okay, the next one you're saying a place, then you're saying Hyderabad. Okay, now I'm trying to understand what it is. Name, a place, then we have something called age. Okay, this guy age is 8. Okay, now his class is 3rd class, let's say, and then we have marks as 100. So Monty is always getting 100 marks, and he is from Hyderabad, and his age is 8, and class is studying his 3rd class. Now it's so quite clear. Even if I show this information to anybody, any lay person who is not working with any organization or is not true professional, also he'll understand. There's nothing here. It's very simple and straightforward, pretty straightforward. A person called Monty who is staying at Hyderabad, age is 8, and class is 3, and he's got 100 marks. Fantastic. Now I'm able to talk, give a story about this guy, right? I'm able to talk about a lot of information about this guy because this information, whatever I'm highlighting, is a data. Once it is processed, I'm getting an output called the complete information. Monty means what? Hyderabad means what? So age is what? So whenever the data is processed, organized, and structured, and we could able to interpret the data in a given context, so that to make the useful and meaningful, they are called as the information. Hope you now understood what is the exact difference. Let me throw you one more example here to give a clear understanding, the final differentiation. I said 25 year. Nobody in the world can guess what is this 25? Is it my lucky number? Is it my date of birth, or it's my anniversary day, or I'm talking about any software, or is it a code? Is it my the class which I'm studying? I do have no clue. But what if I just put some header here saying that age? That's it. Okay, now I got a very clear understanding about this. What you're saying, 25 is an age. So always your data is associated with your information. So the data is processed, then it is considered to be the information there. So that's how we can clearly differentiate between the data information. Now going forward, when we are using, we can be very consciously, we can use what you're talking about. So data is always unstructured, which is not processed. Okay, which is not processed actually. For example, your vegetables is not processed until unless when it is cooked, and when you get the final so-called any dish, that is your end product. That is your end product. So you can simply compare like this: your vegetables are like a data, and your information is your final dish. So for any vegetable, make real sense when it is really properly cooked and properly decorated, and it can be in ready to consume it, right? So that's how the data and information can be compared. For example, you can also say data can be, let me illustrate by the number of likes of the company you're getting. For example, you have your company is on your Facebook, and every day you're getting some likes, or yourself, you posted your selfie or something meaningful information on Facebook, and you're getting the likes. Now I want to understand what is the data here and what is the information. Let me put this way: whatever the number of likes you are getting, I can say it's a data, right? Because it's a sort of number. I got today 100 likes. That's what you're saying. You got 100 likes, that is a data. But how about the information here? Information is nothing but what you can say is it's always represented with demographic kind of analysis, right? You really not sure actually. You're saying you got 100 likes, but who given the like? Is a male or female? You don't know whether is a what kind of age group people are liking your selfies, okay, or analysis maybe, or any documentation, or your picture or a video. You have no clue. So when you start analyzing your data, and when you're able to give the information, demographic information, who's the person who liked your picture, who's the person who's sitting in the corner of the world, how is this guy is from Australia, is this guy is from Brazil, is this guy from UK, US, or any other particular country. So that means I want to have the complete information. 100 people liked my photo. These 100 people, if I group wise, if I do, what is their age group? Whether what is their gender, whether it's a male or female. I want to understand from which part of the country, which part of the world, which part of the city. I want the complete information. So already I'm started using in general word, that is information. So that means the number of likes I got 100. Now if I have the proper information, that is who actually liked it, whether it's a male or a female fans, whether it is from this country or this city or this state. This is a complete package where when you grouped all this information, then it's considered to be processed information, nothing but information, right? So that's a best simple example in today's world, which you can understand whether you talk about YouTube, Facebook, or Instagram, or WhatsApp. Whenever you post something, you are getting something, somebody is viewing it. 1 million, 2 million people have watched, but who are the people actually? So when you try to group them all, that is called as information, not the data. It is a information, not the data. Data is what? Just your likes. But please do remember, data does not depend upon the information. Yes, data never depends upon the information, but information does depends upon the data. If I say age, what? You're talking about age, but what? I don't have any clue here. So let me put this way. As I said, like your data does not depend upon your information. I said 25 year, it's not depend upon anything as long as you're not processing it or giving it information. But your information does depends upon the data. That means if I say age and I've not mentioned anything, it looks really incomplete information or unstructured information. I can say you said age, but you're not giving the answer there. So let me give some answer there. If I say it's at 25 or something, then it's a complete information. So always remember, data does not depends upon data does not depends upon information, but information always depends upon your data. So you can put that way. That's what I was trying to give a weird example. Like if you think your vegetables are as data, your final cooked dish is your information. Or you can say this way, anything which you are getting as an input is in a data, and whatever you're processing, you're doing a lot of data massage to give a clear picture of that particular data, then it's called as a output, right? So input and output. So what is my input is data, and what is my output is nothing but information. You can also consider something like if you want to construct a building, and for that whatever the raw material you're using, I can simply say it's a data. That's it. It's not giving me much information. So the final product is nothing but constructed building. Maybe it's a product. So your raw material is the data, and your end product, that's apartment or whatever the building structure, is considered to be information. Hope you understood what exactly the difference between data and information. I strongly thought before we actually start writing a queries, trying to bring most of the answers what the business is asking. It's quite easy, but before that we need to have the concepts, because it will make you very confident when you're speaking to somebody in the interview, or when you're talking to project managers or anyone for that matter. And especially when you're going for any certifications, these knowledge is really really required, because we always in the real world we think data and information is same, but it's not same. It's always interdependent, I can say, but yes, they are different. So always remember, like that once the data is processed, okay, once the data is processed, let me show you simple terms. I'm not good at trying, let me give a try. This is nothing but your data, okay. uh, Whenever you talk about the data, what happens is it has to be processed, right? It has to be processed. If your data is not processed, you'll not get any information. Even if you take your phone book example, you entered somebody's phone number. So whose phone number? How do I know? Can you put a name to it? Yes, absolutely. In that case, what happens is when you are giving a name to it, that means then it's called as a complete information. Sometimes you are missing its email ID. Still, it is not a complete information. But somewhat I got an information. Okay, this guy number is this. But if you try to give more information, what is his work address or something called uh, what do you call it, a working place address, or external email or internal email or work office number or personal number, colleague number or reference, family members. So that means you are trying to give me more of information, not exactly just data. So just let try to take a look at it. Maybe look a little weird, this kind of diagrams, but this is how it graphically you can remember. Because I strongly believe, like whenever we want to remember something, the easiest way is try to draw it. That's why in childhood, like we've been trained to draw certain things. So this is simply a processing. That's what I can understand, and this is what the information is. So what I'm trying to give that picture here is, uh, we have data in a several ways, right? I don't know from where the data is getting for my company. Even I'm getting a lot of data from my newspaper. I'm getting from some through the form of advertisements. So once the data is processed, then okay, we have a this data source. This is one data source. This is one data source. Maybe thousands of data sources. I don't mind, but all these data sources, when it's being processed, how we are processing, again, that's a different concept, because that's what we are going to learn. Once this entire data is being processed, then finally we end up getting what called as information. So that's how it works in the real world. Even somebody just gave you a number, and you are trying to process that in your brain. Okay, he has given number, he does not mentioning his name. Once he says like, this is my name," then immediately you make a note of his number. A number is already loaded, so you're putting the name also, then your job is completed. That's it. That's how you are trying to, even our human brain works. If you're giving me a number, I don't know it is your credit card number, phone number, until unless if I know the size of the number. If 10 digits, I can understand it is a phone number. If it is a 16 digit, I can understand it's a credit card number. Social security number, like 10 digits. Employee number, of course, I cannot compare because depends upon the company. So whatever it may be, when you give some number, I can never understand. So you need to properly associate with the information. You need to give the complete information. So that's all about how your data and information looks like. So All right,
Shravan,
Rish.
Shravan, just
Shravan, one
saying
small
that.
doubt, Shravan.
Let's talk about a very important topic now. Everything is important, guys. I keep using this word important in terms of especially, not only specialist, what I've seen in SQL, the concepts what we are learning, everything is interdependent. If you're not understanding one thing, you'll definitely, there are 100% chances you're not understanding the next topic as well because it is interdependent. When I'm talking about the data, you need to know what is information. If you're not understanding data, you can never understand what is the information. So it's all interdependent. All the topics are interdependent. So let's talk about the very important one. What is database itself? Okay, very big question. What is database? I don't want to go too far actually. I want to look at my notebook, which I used to maintain in traditionally. Okay, I used to have a notebook where I used to uh, put all my monthly grocery items expenses or whatever the expenses I have, whatever the incomes I used to get. Okay, I used to collect rent, so that is my income. I used to get salary, that is my income. I used to get my interest on my capital invested in some business, that is my income. I used to write everything at some one page. In the next page, I used to put what are the expenses I paid for the milk, I made for the electricity bill, all these expenses or whatever the groceries you purchased. All this I used to do. I never had this computer, I don't know this technology. I used to use a simple notebook. Even our forefathers used to use this kind of stuff, right? We used to use a notepad, notebook for that matter, and write in the information. Now, what is the drawback in that? If you look at the drawback is, I very neatly I maintained a notebook. My friend name, I put a serial number. My friend name, his address, his phone number, and his working location and his company name. Very good, excellent. One record is recorded in your notebook. I'm talking about a simply notebook. Likewise, I created almost 100 records. I hope everybody accept like somebody's phone number is changed. We used to go to that particular line and you need to strike off that only phone number. You used to write either at the top, either at the bottom, either at the left, either at the right side. That's how you used to manage, right? You need to cancel it and you need to edit it, or you simply strike off that entire row and you used to write at the bottom. Even if you're striking off, it is not going away from your notebook. It's still there. So sometimes there may be a duplication of records which you can never understand. I entered your name, your details, and maybe in the next page also I entered your name and details, because I don't know whether I've recorded or not, because I'm maintaining some thousands of friend list information. So it's for anyone it's really impossible to check one by one row if this name is already existing or not. So that's how I started using this index. If you guys remember, there's a diary. It starts with alphabet A. All that information with any friend whose name is starting with A, I used to record all his information in the A page. B stands for all the B related guys information. C stands for C related information. That's how I slowly upgraded myself from so-called notebook to this kind of graphical presentation of indexing type of information. So that's how at least if somebody asks, can you tell me his phone number whose name starts with like M. Okay, I definitely what I'll do is I'll not go by page. Directly, I'll pick up that M letter page. I'll try to look for his name. So at least my burden is reduced, not that much where when I used to use the notepad. So in real time, that's what I keep using this word. In real time, you're already a database kind of administrators who are managing effectively the queries. Query is like your friend asks, can you just pass his number? Then definitely you'll ask what is his name. So once he says name, you're searching in the search pad, and on your keypad there is a search where you search his name. Okay, once you find, you're trying to share his number, right? You're searching it. Somebody said that guy is not existing anymore, so you're deleting it. Somebody said his number is changed from Airtel to some other number. Okay, some number. So you are editing it, you are deleting it, you are dropping. You are doing already these operations. The only thing is now you need to shift our mind, not leaving our smartphones, by the way, but we need to shift our mindset from the smartphone to this technology. How I can do a big difference in the corporate world by storing my valuable company information in some shape. What is that shape is called as a table, right? So you are going to save all this information or data in the form of table. So typically, if you look at an Excel, Excel is the best example actually. If you look at the Excel, we have a lot of information. We have some 10 columns, let's assume 10 columns, some 10 lakh rows. So if I need to understand this data, just straight away, I assume that I've never seen this data. First time when I'm looking, my eyes goes to the first row to understand what kind of meaning it's really giving me. Okay, the first column says employee ID. Okay, immediately understood. Okay, the entire column is talking about employee ID. Second one is employee name. We have a date, but if you don't have at the top, we'll never understand it is a date, is anniversary, or is date of birth, or it's a date of joining or date of retiring. I can never understand unless we don't associate it with a proper heading. So always remember, it's in the database. Okay, the data is stored in the form of tables, and the tables are called as a two-dimensional. One dimension is your row, one dimension is your column. So it's always called as a two-dimensional. And please do remember, always you try to store structured information into the database, because database cannot understand unstructured data. So there are other tools which we try to use to process that unstructured. We have a machine learning language, artificial intelligence. Okay, we have a deep learning, we have a neural networks. We have a lot of things. Other tools, Python for that matter, yes, it will unstructured data. It can make it structured to make a meaningful information. So here we are more or less we are talking about a data which is straightly coming from my in-house systems, which I'm trying to store in a typically in servers in a database, because my company said like we need to maintain the historic data. We have data from 1947 to 2021, so I can't manage in Excel. Okay, I can still manage in Excel every year one file. So that means 1947 to 2021. So I need to maintain some hundreds of files. If I have a different countries I'm dealing with, different countries. If I'm dealing with regions, dealings. So if I'm maintaining a different products Excel files. So just imagine a lot of confusion here. I cannot manage in a Excel. I can't even go for a access because so much of records. Again, depends upon the company. There are few companies still dependent on MS Access. I'm not saying it is completely not in this world anymore. Access is still there and is doing its good job. The only thing is when it's going over ahead, I cannot use the access, because now we heard in this today's session, two people are already in the process of migrating from MS Access to SQL Server. That means the company is looking out to migrate. So one and only reason would be they are not able to manage MS Access anymore. They are not able to, they are not happy with the data, what kind of data which been stored in Access, and most of the people are not able to access it. So what if I completely move this data into SQL, so that anybody from any part of the world can access? Okay, obviously we need to have an access, right? So once you have an access, then you from any part of the world you can access this table simultaneously. It's not like you're working, let me hold on for some time, once your job is done, let me start querying the table. No, multiple users, multiple times, you can start hitting the database to get the information. For example, from my system, if I type www.google.com, that means I'm sending a request to the server. You're also doing from the phone, somebody is doing from the iPad. It is trying to take the request from everyone. That is what multiple users accessing certain systems, right? So everybody in the world at a single go at the same time, we are able to query the same information. Query is nothing but I'm saying www, this is what my query is. Can you please display a Google page for me? That's a question, what I'm asking. So when I'm doing, it's need not to be, you need to be hold for some time because let me finish my job, then you log into the Google. No, we can also log in, I can also log in, multiple people can access the same thing, which is happens only this relational database management system. So what does it mean? MS Access is not a relational database management system. Yes, it is, but it is a desktop application specially designed and developed by Microsoft. It is only a desktop application, so you can never make it available for the entire organization. Just go and look at your company. Whoever is using MS Access, probably they are using for their process specific, or two members are working together. Probably they want to have some database where only two people can use it, three people can use it. Within the process, you will see, but not an organization which is maintaining a database called Access and asking everybody to access it. No, it will never happen. So it is only to store a small amount of data. So never think about huge data can be stored in Access. Even if you're successful in storing, going forward, you'll see lot of issues in handling these Access databases. It can be deleted anytime. It can be deleted anytime by anyone, because you have to keep it in a shared drive or in your shared path. If you keep it on your desktop, only you can see, not anybody else. So that's about the desktop application. We are not talking about a desktop here. We are talking about a relational database management system. Okay.
Shravan, are you there?
We are not able to hear you, Star.
Yeah, Shravan.
So we are talking about a database management system. What is database actually? Not even interested in DBMS. Okay, first I'm interested in database. As I said, like MS Access is only a desktop application. It cannot be used by a bigger organization or small organization still using, but it is a process specific. Process in the sense you have a manager, you have two or three executives who are working under him. Okay, to manage your that process to your business, it is okay. But if you're talking about multiple processes, multiple departments cannot use that. You can never make MS Access to use widely in your organization. So that's why we have some relational, we have server based in the sense, example is I'm just taking an example of website, but practically we are talking about a databases here. I'm able to use Google from anywhere. I'm able to access as long as I have an access. Okay, here what I mean access is I need to have the internet connection. I need to have the proper access to go to any site. That is what I mean to say access. So that means from any corner of the world, I'm able to access because it is a server based. So whenever you talk about a server based, that means we can access from anywhere, right? Example to low level to understand, if your company is putting all this documents, office documents in a particular shared drive, you can access from any corner of the world if you have the access to that shared drive. That's about it. So here what I mean to a database, I've been talking about database again, like my best example is my smartphone and my phone book or notebook or simply a notebook, right? So the database management, you can think about like this. So uh, coming from a node back to then going to a index kind of information. But when you specifically technically talk about database, it's just a collection of information, right? It's just a collection of information. But again, I'm talking about the data again shifted to information. So that means even though you are not intent to use that, you will interchangeably used. That doesn't matter. Okay, that doesn't matter whether you are using a data or information. So basically, a database is a collection of information that is organized in such a way so that everyone everyone can access it, because now the information is structured in so beautifully in the form of table. Anybody can easily access. So that's about the database. Database talks about only the information which is being stored. But again, database holds the information, not really. Database holds the data, not really. Database is just like a skeleton in which you are going to find little objects called your tables. So a lot of questions behind this again. How many databases I can have? Again, depends upon your organization. You can create as many as databases, and how many each database can hold tables. No matter how many tables, it's again depends upon your requirement. How many tables you need, how many tables is the requirement for that projects. There is no limit. So here, what should I learn then? First, you need to understand how to create a database, how to create a table, how to create a second table, third table. That's it. You know how to create multiple tables, multiple databases. That's how it's going to work. All right. So basically, you need to understand a database is a collection of information that is organized so that it can be easily accessed by any person in your organization. Which is again, it is only holds a structured information, but not unstructured. As you guys know, what is unstructured and what is structured, right? Structured is nothing but look at your Excel. Look at your Excel is a structured data because beautifully it's showing in the form of rows and the columns, very beautifully put it in the form of a table format, where anybody can understand. What is unstructured? I can say if you try to download your Facebook information, is unstructured information. If you look at WhatsApp information, that's unstructured, because when I download it, I will be getting here and there. I need to again put it in a proper format. Then only I can call it as information. So it is unstructured until when I just don't process it, will not become a structure. But here in a database management system, we always talks about structure only. There's no such buzzword called unstructured. Unstructured, there's another models which are dealing, that's machine learning, deep learning, neural networks, artificial intelligence, Python for that matter. That's the biggest tool which has been doing a lot of data massaging. So here, as I said very clearly, it is whatever the information you are getting in the company, which is a structured information, you are putting in the form of a table so that it can be consumed by your business user, or anyone for that matter, your manager, your CEO of the company. When he want to retrieve, he can retrieve. So that's about the database. Database just stores the information, not directly by using the object called table. So just imagine something like we have a database here in which you will be finding a small database systems, something like this is my database here now. This is one database. This is one database. This is one, sorry, this is your entire database here. Under that, we have each different sizes of tables, because I don't know what is the size of the table. It depends upon the number of tables you created, and each table has a different size, right? Some table has some static information like 10 rows. Some tables might be having, as of today, 10,000 rows, and tomorrow with more transaction it may increase or it may decrease. So this is what happens. The size can never be a constant. Each table, that's why I just try to put in a different shapes and sizes here. It can never be same size. So you'll have one database. We have one database and we have all the tables sitting under that database. Can I have one more database? Okay, the question is, can I have one more database here? Definitely you can have. Just you can create one more database and you can create multiple tables here for your company. You can create as many database, but people prefer to use one or two databases so that they can easily manage it. One database for entire finance, one database for entire operations, one database for sales, marketing, whatever. So you can have one database with all the tables. You can have multiple databases with multiple tables. This all depends upon how you are going to design it, how you are going to structure it, so that it can be freely, easily accessible for the any user. So that's about what is a database here. Database is basically is a structure which is going to store some information in the form of structured information in the form of tables. And tables, for that matter, you always try to remember this techie word. It's a two-dimensional form. Two-dimensional is nothing but like a row and a column. That's why it is called as a two-dimensional table. So that's about database, how it works. So your Excel is the best example of a database, actually, because I keep looking at Excel, so I am not stopping my urge talking about that. Uh, Excel is the best example of your database. Look at any sheet, you will have some data there. Okay, in the form of rows and columns. Notepad is also a database for me because I stored a lot of information today. I've written something called data, I've written called something called information, I've written some information. This itself is a database for me. But what could be the challenges here? Tomorrow, if you want to search something here, it's a little bit difficult. If you want to delete something, you need to find that person and delete it. And by mistake, if you deleted the real important information, you can never get it back. So a lot of issues in this kind of information. If I'm putting information in the notepad, at least in the Excel, I can still see the rows and information structurally aligned in the form of cells, so I can easily manage. But notepad a little bit difficult. So the next one is let's try to understand the next important buzzword. What is DBMS? Before I talk about DBMS, we already know the what it stands for actually, but I want to break it down and understand this. Once I give a space here, what happens? Okay, there's a little space, but there's a lot of information here. DB stands for database. MS stands for management system, right? Okay, database management system. We always try to use this word as a single word. Yes, of course, we have to use that way only. DBMS. DBMS stands for database management system. When I separate this, what happens is when you try to dig more, it's nothing but it is telling you there is something called database which we are trying to use a system. You are trying to manage the system. That is what MS stands for, database management system. There is a database which you're trying to manage it. How you're going to manage? Let's see. So DBMS stands for Database Management System, and it is a software. It's a simply software. Okay, if I'm installing Microsoft SQL Server, that's nothing but a DBMS which I just installed from Microsoft. If you are installing MySQL, nothing but it's a product from Oracle. If you're installing Oracle itself is from Oracle again. Uh, if you're going for any relational database, when you're trying to install some software, what happens is you are trying to install a software called, okay, internally DBMS. It's a software, that's it. You cannot see physically, but it's a software which basically used for creating or you're managing the data in the database easily. Okay, only this is a software which is going to help you to manage effectively and efficiently these databases. So it is basically we can put this way, it's basically a set of programs, right? So which is trying to store the information, modify it, updating it, retrieving it, whatever the other things which you want to do for the database as per your business requirement. So DBMS not only just helping you in terms of saving the data or retrieving the data, but also it provides you a security, right? Just imagine you are putting all the information in the notepad, notebook, traditional method. Again, let's go back to the one step back. Notebook, you are putting a lot of information. By mistake, if you are, okay, remove the page, your database is gone. If you lose the book, your database is gone. What if you lose your smartphone, not yours, mine? If you lose your smartphone, that's it. That means your database is gone. We cannot retrieve it. We have other ways, but just imagine in this way. That means I do not have, we have any security here. We do not have any security. We do not have any protection. So anything we always in the real world when we are doing something, if you don't have a real security for it, if you don't have any real protection to it, we always scared about it. So I'm really scared about notebook, right? Because I need to maintain it. I'm not sure if the notebooks will be safe for next 5 years or 10 years. I need to maintain it, right? So even your smartphone. So in terms of a database management system, what happens is you will have a security and the protection. You can also always keep saying, what if your database software is corrupted? What if your database is got deleted? What if your database is not properly aligned? Not to worry, every day there will be a backup. So that's why database administrator plays a very, very important role here. Whatever the single transactions done by a banking, okay, or in the ATM, whatever the transaction is done, it will store in the main database. At the same time, it will go and sit in the backup server also. So that's why the data is being stored in a different places so that we'll never lose our data. So that's a kind of security what we can see in the database management system, and also protection so that you'll never uh, repent that we use the software. So we need to keep in mind what is DBMS. DBMS stands for Database Management System. It is simply a software. That's it. It's simply a software which is trying to manage the data what you're storing in the databases. In the databases, right? So if you ask me what are the examples of this database management system, there are 50 plus database management system. We have right from Access also, we can take MS Access, you can take MySQL, you can take Microsoft SQL Server, you can take Oracle, you can take DB2, that is from IBM, right? So IBM, DB2 is also there. So there are different types of a database management system. No matter, we are not digging more into details which database is best or which is not, which is the best product. No, we are trying to learn the query management here. So once you know the queries, irrespective of the database you are using, it's a same we are going to write the query and we are going to retrieve it, we are destroying it, or you are updating it. So that's about the database management system which works. All right, so far we have just covered what is data. To understand more, because we are getting into a data analytics world by using a language. We are learning altogether a new language called query language. Okay, it's not new. For us, it's a new. We spoke about what is the information, how those are interrelated dependent, what is a database. Of course, we have not spoken much about tables because we have to see it practically. Database is like empty space, we can say, where we are trying to put all your blocks called tables, and in the tables we are trying to store information in the form of rows and columns, which is called as two-dimensional, which is called as, you might have heard this word, tabular format. Okay. And what is DBMS? We have seen DBMS is nothing but a simply software which will help you to store the information, to retrieve the information, to drop some information, to update some information. It will help you to do a lot of things. All right. So with the help of DBMS only, we are trying to create the databases, and what all the functionalities we are able to do it just because of that software. Let's begin with the next topic. What is I want to understand what are the uh, components of DBMS. Okay, what are the different components we have for the DBMS? For sure, one thing would be you'll find software. Okay, every DBMS core component itself is a software. Without software, nothing can work on. And the next would be you can easily imagine what could be the next component, nothing but hardware. Okay, Hardware, why every time the software is associated with the hardware? Because if I want to install Windows operating system, for example, I need to be very much bothered about what kind of RAM I'm using, what of CPU I'm using, what is my hardware configuration. I need to be very, very clear. Okay. So when you're trying to install some huge softwares, definitely it recommends you need to have minimum of 1 GB RAM, you need to have 1 GB of hard disk space. It will have its own requirements because it depends upon the size of the software which you're trying to install. For example, if you are installing MS Excel, it can be loaded because a lightweight software. Okay, if you are loading this, installing Python, Python can install, it doesn't require much space anywhere. Okay, and if you're installing SQL Server, we need to think about only one thing. Do I have 1 GB of RAM minimum in my laptop? Do I have a minimum of 1 GB of space where my database can freely float and can easily be able to access it? So these are the minimum things which we always consider whenever you're trying to install anything. Even in the case of a smartphone, whenever you're installing some apps will not be loaded because of incompatibility or your version. Maybe Android has a different versions, right? Ice cream, sandwich, chocolate. Well, I don't know why they are beyond of just bakery items, but when you look about these different operating system, and every app has a different kind of compatibility of Android operating systems. So we need to always be bothered. That's what I'm referring. Components of DBMS software, hardware primarily plays a very important role. And the next one is procedures, which says procedures, we can take it this way, like procedure is nothing but a set of rules or rules which you're writing in the form of syntax, commands which you're writing to hit the database to get your what you require the information. Okay, it's a simply a procedures. Let's take a simple example, VBA. For example, I want something to be automated. I want all the workbooks to be consolidated into one workbook. It's a simple exercise, right? So it will not be done automatically. There is something to be written procedures. We need to follow some syntax. We need to declare some variables. We need to do certain kind of a programming there because that's a VBA. If I'm writing in Python, Python has its own style. SQL has its own style. If you're talking about a C, C++, these are all programming languages. It has its own style. Again, why? Because that's how the software is designed. So every program will have a set of procedures which we need to follow in order to make a robust application and to make it a really productive one. All right, so that's a procedure, real components. This topic, why I'm picking up it is maybe not somebody will ask you what are the core components of DBMS, not really. But if you just come across any certifications which you are planning for in future, definitely there will be a question to be asked like what are the core components. If you don't know what are the core components of DBMS, that means you don't know anything. If you don't know what is the real meaning of data, if you don't know what is the meaning of real information, these are all core concepts which I'm referring, which can be really helpful in terms of interviews or when you're talking to your colleagues or project managers or anyone. These are the real words to be used. The next one is data. I can't talk about much about data again because without data nothing can happen. It is data. It's like a fuel. That's what everybody is saying now. Data is a fuel for this generation, right? So without data we can't do anything. The next one is not the least one, but very important again, the users, right? Uh, which users actually? Is it a business users, end users, or uh, database administrator? Who are the users? Anybody? Okay, if I'm managing the entire database management system, I'll be designated called as a DBA, right? Database administrator. We'll talk about that again, but let's try to keep it very simple. If I'm a user, end user, who's just somebody has created a table for me, I'm just accessing it to create a best report for my business. So one kind of a user, end user. You can be a database administrator. You can be an application programmer for that matter. Okay, so user. So these are the five components which makes up your DBMS. It must and should have these kind of components. Software, as I said. Second one is hardware. Third one is the procedures. Fourth one is data. Fifth one is users. Hope this topic is clear. Core components, what exactly makes up this DBMS. Now, let's try to see what are the different type of users who plays different roles altogether in any organization for that matter. Okay, in any organization, different users will play a different roles. Might be in our group we have a DBS. Maybe some people are not technical guys, but still using SQL to query the data for their reporting purpose. It could be any kind of a form actually. So let's see roles in DB. All right, that's a simple one. Roles in DB. The first foremost kind of a role which you can always see is your application. Okay, application programmers, and you will find what is the second one would be your database administrator. Okay, very important. And let me just make it database admins. And the third one would be third
Shravan,
one.
sorry to interrupt. You're not sharing a screen share.
Guys, nobody has told I'm recording actually.
No. We are able to see. I am able to see basically.
We are able to see you.
All right, so we are talking about the core components which you have seen: the software, hardware, procedures, data, and users. Now, I want to understand what if I learn this SQL, or when I'm getting into this kind of a database management system, what are the different roles we can play, or what could be the different roles we have? Okay, in different organizations, it's called designated as a different things, but when we pick up the more three important roles, we can see application programmer. One we have is a database programmer. Okay, one we have is a database programmer, database admins, nothing but called as a DBA, and the end users. Nevertheless, the end users. Okay, so let's talk about application programmer. Who is the application programmer? Application programmer is it related or not related? How, what kind of a role he's playing in this database management system? Any user, okay, any user who is good at application, designing the application for that matter, by using any programming language, like maybe a C language or C++, Java, Python for that matter, by using these languages, even VBA can be considered as a one programming language, right? So using any of this programming language, when we are trying to interact with the database, this guy is called as application programmer. So that means I'm a programmer. What I'm doing is I created, I know a Python. So what I did is, with the help of a Python, I written a program, okay, which also can interact with the database. Okay, let's assume in simple terms, I created some railway reservation kind of interface, or a restaurant interface. Okay, any restaurant interface or any supermarket interface I created. So this is being designed and developed by using a Python. It could be any programming language, but when I started feeding this application, where this information is going and sitting, it is going into the database. So that's how I am called as application programmer. So basically an application programmer where I'm using the languages to create the interface. Finally, it is trying to store some information behind the scenes. Okay, either you're storing information, either you're deleting it, either you're updating it, whatever the operation you're doing, then it's called as application programmer. Then database admins. As I was keep telling, like when you are learning SQL, it doesn't mean that you'll become a database admins. Database administrator, DBA, okay, SQL DBA, okay, SQL Server DBA, Oracle DBA for that matter, MySQL DBA, DBA, what exactly this DBA is, database administrator, who will be sitting in your organization. You will be sitting this side where you are creating database, you are creating the tables, but finally, to provide a security for it, to provide a user access for it, to provide which person has to access which tables, how much control mechanism he can do. Whenever you are leaving the organization, he has to revoke that access. Whatever the functionalities as an admin supposed to do, okay, he will be performing those actions as a DBA. And again, DBA, you'll see most of the time he will be using a graphical interface like Windows Explorer. When you right click on a folder, you can rename it, you can delete it. These kind of functionalities which is going to do in the database management system. So it's a different role. And again, the question is, if I learn, this was the question raised in the demo, if I learn SQL, can I be a DBA also? Can I only be restricted with SQL developer as a SQL developer or DBA? even if I know both, I cannot play both roles in any organization because nobody will allow you. The reason is it's a toxic combination. That means you yourself creating a table, you yourself modifying it, yourself creating an access. That means you have end-to-end access. That means you can manipulate anything about the customer information of a company. So that means strictly you'll be playing a DBA, I'll be playing a SQL developer. So that's how the control mechanism can be managed in any organization. So typically you'll find database admins are different and SQL developers are different. No matter whatever the role it is, so database admins or SQL developers, both are using the same queries actually. Okay, to retrieve, I'm using a different command. To provide an access is using a different query. That's it. So both are using SQL as a medium, as a query language to do the operations. But he's playing a different role. I'm playing a different role. I'm in a kind of business user who's trying to extract information to create the reports. But that guy is not creating a reports. Rather, he's trying to provide you a robot security system for your database. And every day, he'll ensure that whatever the data you're feeding to a database, whatever you're updating, whatever you're deleting, will ensure that this entire information will go to a backend server as a one of the backup. Anytime if you feel that you dropped a table and you later found this table is very important, don't worry, your DB will help you in order to that drop the table also you can retrieve, because you always maintain that security and the protection for your tables, because he will have some backup servers, backup tables, whatever you create. Every action when what you do on the SQL will have a one backup. That's how we are able to maintain the security. So hope you understand what is the application programmers. Application programmer is a programmer who will use any programming. I'm not stick to Python because it's famous. No, even if I'm learning a C language, with the help of a C language, when I'm trying to create any application, or Java enterprise version, if I'm using to create any application, behind the scenes, always you will find a database. Just take an example, any social media, Facebook, okay, YouTube for that matter. You are posting a lot of videos. You are able to watch the very old videos. The only reason is somewhere behind the scenes, somebody is sitting and storing that information in the form of tables. So that's why whenever you search any data in this internet world, you are able to retrieve because somebody is managing the data behind the scenes with the help of a database management system. Hope that is clear, and we know very well who's the end user. Anybody can play an end user. For that, you doesn't require any designation as such, like you need to be a SQL developer. You could be a normal user who's not related to technical functionalities. You are not related. You are not a technical guy. You are not a software developer. You are not an analyst. You are not a data scientist. You are not a business analytics person. But still, when somebody says, can you log into this server and get this data, download to Excel, uh, download to Excel and create a graph for it, so immediately you'll do that. So any person who is having a proper access to the database can be an end user. End users always sees the information. He cannot do much. Okay, that's about the roles what you play in a database management system. But in today's world, what is happening is, earlier it's most of the time it's more of job of software developers or SQL developers. But nowadays, everybody is playing all these roles, because your company is making you to work on these technologies, because you're working for a particular kind of a department where your data is being stored in a server, and one or other day you will be get trained to how to retrieve the data from the database. If you are good and you can show off your skills, that I can also do create a table, I can join the tables, I can do much more than just retrieving, then good to go. That means you are going to have the complete SQL knowledge. That means it's not just retrieving, you can do much more things. So that's about the different roles what you can play in any organization, a typical organization. There are many actually. Different people call it a different ways, but when you just combine into three different roles, this is how it comes out: application programmer, database admins, and end users. Okay, so hope this is clear. Uh, to talk about few more topics. Just a quick recap again. Roles, what you have seen is application programming, database admins, and the end users. Now let's see where we can apply actually, because we are talking about this now. I understood what is data, what is information, what is DBMS, what is database, uh, what kind of role I can play. But now I want to really understand. Without this understanding, I cannot go further, because I need to know where it can be what are the different applications I can use for this DBMS. So let's say applications of DBMS. Okay, what are the different applications? There are various fields, right, where we can use this database management system. Even first of all, there's no need of field actually. If you just talk about as an individual person, I have a smartphone where I'm storing a lot of information. As an individual user, I don't have any designation. I'm a normal human being who is just trying to store information in the form of uh, some contacts or in the form of images. Your image photo gallery is also a database, right? You want to look at how you used to look in the last year, you'll just go back to that particular date and check your selfies, right? That's nothing but you're storing historic data and current data as well. So where I can apply, there are various fields where the database management system is used. Okay, let's take a simple example. If you talk about the library management, we always used to go to a library. So if you look at the library management in traditional manner, how it used to happen, somebody was sitting there who is managing this library, who will have a big notebook, who will make a note who is the person who entered into the library, who has picked up the book, who has taken us for the rent, when he is going to return, how much amount is paid, and when he is going to return back. Once you are rating his book, definitely we'll just say okay, he's paid and the book is been uh, got back to your library, right? So this is how typically we used to manage traditionally. So there's a lot of books in the library, right? So whenever the list is being increasing, it's really tough to record all this information in a simple register, so-called, or book, whatever it may be. Now the database management system is used to maintain all this information. Whether you're using a Microsoft Access or SQL Server, I'm not differentiating it. We are using some database management system to maintain all this information related to a name of the book, uh, uh, when it is issued, maybe, or on which date, or what is the availability of the book. Okay, if I want to check my stock, do I have this kind of horror related books, how many copies I have, do I have that copy which the user is having. If I want to check, I need to physically go and check each rack, each on the subject, to see whether the book is available. Now it's not required because you all stored all this information in the form of a database. So that's a simple example what we can relate to library management. To give more information, if you talk about the banking, okay, we have a Bank of America, JP Morgan, we have a lot of companies, HSBC. They they are not just using Excel or MS Access, they are using a huge servers, because their transactions are not 1 or 2 million, it's trillions, sometimes go to a zettabytes, right? So I need to have a proper system where I can store all this information. So servers comes in handy, not just desktop application or your Excel. Of course, these applications still alive. I'm not saying they are rolled out. They are dead. They're still there, but to store a small piece of information where you can quickly try to bring some insights. Okay, so banking is the best example where they try to use the database management system to store all their daily transactions, maybe, okay, payment transactions, or the customer information. Okay, I have some million customer in my banking. So where do I store all this information? I need to have a proper database, because customer tend to change his address, customer tend to change his phone numbers, his email ID, he may change his spouse. What is all this information I need to update somewhere else, so that quickly I can answer any question when he's asking me. I can hit the database and get the information from here. Okay, so if you talk about credit card stream also, what happens, like what are the different transactions I'm doing. Even if you look at your credit card, you religiously, what you do, you'll pick up your phone or your notebook. Okay, on the January 1st, I did this transaction through the credit card, so this is my outstanding. You'll try to put all this information in a notebook. Now we are talking about a large scale in a bank. Just imagine, millions of users are using their credit card. All this transaction has to be stored somewhere. Is why you're storing actually, because end of the month I want to bill how much you have to pay as an outstanding, and how much interest I need to charge. So all this information, when I have in database, I can easily analyze. I can send you a monthly bill or quarterly bill, whatever it may be. It will basically help you to score your credit card. It will also help you to generate the monthly statement, as simple as that. So credit card is one of the best example we can say. We have seen what is the library management. We have seen We have seen what is that other thing? One we have seen library management, credit card management. We have seen what happens in the banking domain. The next big part, of course, social media, right? We have Facebook, we have Instagram, we have Twitter, okay, we have WhatsApp. All this information, we all use this social media website, right, to connect with your friends or to share your opinion, to post your videos or photos. Millions of people are doing. It's not one people or only India is using. No, well, a lot of people from every corner of the world are using. So by the use of these database management system, what happens is all the information will be stored in particular place so that it can be available whenever you want to connect to a people, whenever you want to share your views, whenever you want to retrieve any information. The best example would be your Facebook is using MySQL as a database to store all your historic information, whatever you're doing. You're deleting, you're actually your picture or a video, when you're deleting, it's not really getting deleted. Just for the interface is getting deleted, but actually it is going and sitting somewhere else as a backup data also, so that future also we can retrieve it. That's what happens. To be more precise, there are millions, let's assume millions of users for the Facebook, and everybody has their username password. Who is storing this information then? There is a database. There is a particular table which will store all the users, their password, and what in case if you forget the password, how to retrieve. There is a secondary email. So all this information might be, they have, why I used a might be, because I don't know how the database is designed. When I pick up a project, I'll be the person who will be designing the database. So it's a mere guessing. Might be they have a table where they have the user table with all the usernames and the password and the secondary email and their phone number. Might be they're stored in that fashion. And there is another table where this particular person is storing all these photos and videos or any links or anything. So it could be anything. How the database is designed, we never know until unless when you make your hands dirty, when you're really working on your live projects. So that's about how it works in the real world. We have seen the social media, library management, banking domain. We have seen credit card. If you talk about the telecommunications also, what happens in telecommunication, we can easily guess actually. Without database management system, we can't think about a telecommunication actually, basically because it's necessary for these companies to store the call details. Can we imagine every second how many calls outgoing or incoming? If you really want to manage this, okay, if I want to give a bill, monthly bill, post bill, how many calls you made this time, how many incomings you used, how much MMS you used, how many messages you used, how much data you used. If I want to really validate all this information, I need to have this, right? So for that, I definitely require once again a database where I'm storing information so that I can generate a monthly bill for you. That is a postpaid bill, okay? Postpaid bill. So that's what you can also relate to telecommunications. And last but not least, online shopping. Yes, everybody is interested to do the online shopping. It's not just because of pandemic situation. No matter, we already got used to this online shopping, right? And it will be there forever. Example, we have something called Amazon, we have Flipkart, Snapdeal, Myntra. We have all these uh, shopping sites. So why we are going online? Because we don't want to step out. We don't want to waste our time. We want to just look at the pictures. We want to buy it online itself. So when we these guys are displaying some information on the Flipkart or Amazon on some offers, these information are keep changing, right? It is not static always. It's keep changing. Whenever there's a new version of a television or any smartphones, they keep changing it. It's just happening because this is an application. Okay, if you take a Flipkart, which is being designed by using some web development languages, maybe, okay, by using HTML, Java, maybe by using a Python, they have created this website. But behind the scenes, again, there is a data which is being stored. All right, so completely it's stored. Even if you take your best example would be your Google. Okay, nowadays your Google is tracking where you are there in the last night and what you are doing in the next morning, which are the places you visited. So nothing is so privacy now. It will highlight last week during where you are, what you were doing, which places you visited. It is able to track everything. So because it's storing some information somewhere in the backend server. So that's all. Online shopping is a very, again, a best example, one of the best example I could say, where it can store all the information, and whenever you want, you can retrieve it. So that's best thing. And even if you look at your education sector also, that's what happens presently. All the examinations, okay, presently, yes, yeah, presently examinations are all conducted online. Okay, many colleges, universities as well, and they manage all this examination data through a database management system, because they might have created the questions and the answers in the database, and of course the answers are not displayed on the page but only questions. So when you're clicking, either the question, for the question answer is true or false, when you're clicking, based on the application program who is designed, based on that it is hitting the database and trying to cross check with the database whether the answer is true or false. So basically you can see even in the education sector, the database management system is there. Banking, it is there. Library management, it's there. Even if you talk about this railway reservation counters, right, system, it's really, really not possible to understand if the train is delayed or it is coming little uh, late, whatever situation. If I want to know the updations of the train systems, definitely again I require a database management system, because if you look at a railway station, there are a lot of displays. Okay, this particular train is arriving at this time and departure is as deep, and even airlines also same thing. Even road transport, anything if you take, this information is dynamically keep changing, because behind the scenes the data is being updated by someone. Okay, today one particular airlines is scheduled at so and so time, but it is got delayed. How do you know? Because behind the scenes somebody is updating it. Flight is cancelled, so delete the record from that. So this is what practically you can think about in the real world examples, railway regulation management system. So hope you guys understand where you can really apply. It's not only just a corporate world what you're thinking about, not simply on my laptop where I can start creating it. Yes, everywhere the data is existing. As long as the data is existing, I need a database. Without database, I cannot think about my life, think about my survival, because every company is revolving there on the data itself, right? Airline reservation, okay, maybe RTC, whatever you talk about. So these are the different applications where we can see the DBMS concept. All right, after seeing applications of the DBMS, that means where all I can apply and where I can visualize, I mean, which system can be used. So that's how we have seen some examples like railway resolution, or maybe airlines, maybe RTC, maybe library management, banking domain. Everybody needs it actually. For that matter, even I need a database to store my phone contacts. Okay, to store my phone contacts. If my business is increasing, obviously my phone will not be as sufficient. I need a more space, so I'll shift myself from phone to iPad maybe. From iPad later, I thought it's still not manageable. I may move to a laptop. When I move to a laptop again, I may start using a simple notepad because I'm not aware of Excel. Notepad is also becoming too much for me, then I will shift to Excel. Excel is also becoming too much for me, I'll go to MS Access. Again, the question continues. My MS Access is also not able to handle because it has a limitation of 2 GB. So what, when I want to really extend my wings and start storing your millions of transactions, definitely you require servers like Microsoft SQL Server, MySQL, IBM DB2, whatnot. All right. So that's about applications of DBMS. Let's see the types. Very important, because so far you reached to this seventh topic called application. We need to understand a little bit about the types. Once you understand the type, the real challenges comes here, talking about SQL and everything. DBMS. Okay, so the first one, the types of DMS. Basically, there are typically I categorized it as a 4 types. There are many, in fact. Different people has a different opinion on this. It's always a debate continues on that. But I categorize as a 4, and very, very important categories. These are, the very first one is HD. I'm not writing everything. HDBMS. Nothing but it's kind of a hierarchical database management system. Okay, it's called as a hierarchical. Let me write here so that you can record it. Hierarchical database management system. The second one is, now you are coming to the actual portion here. The next one would be NDBMS. Nothing but this is called this is called as a network. This is a network database management system, and this is what you'll find as wo okay wo DBMS. Little complicated to pronounce, but we'll talk about that. This is nothing but object oriented. And the next one, the one which is we are intended to learn, that is RDBMS, nothing but relational. Okay, our main agenda is to understand RDBMS. To reach to this particular topic called RDBMS, we spoke a lot of things because we want to understand right from the basics. So the first one is SDBMS, nothing but hierarchical database management system. Okay, this is a one type of a database management system. We have a network database management. This again is a second type of one. The third one would be object-oriented programming language. You might have heard. So here I'm talking about not programming language, but it's a object-oriented database management system. The fourth one, favorite and very important, that is what we are intent to learn, that is RDBMS. RDBMS basically stands for DBMS, database management system. Additionally, there is a letter called R, which is a relational, making relationships. Okay, so making relationships, that's the main thing about the relationship management system. So if you try to just to have a word how the hierarchical database management system works, it is typically a system again which has the data elements, and it has a one-to-one relations. Little confusing here, one-to-one relations. So that means this hierarchical database management system works like a tree structure. Okay, it works like a tree structure, similar to let me go back to my Windows Explorer. This will explain very better. I'll go to my C drive. There is something called Windows. When I click on Windows, I have further folders. When I click on cursors, there's a separate folders again. So that means this is the best example of your hierarchical model. That means your data being stored in the form of a tree-like structure. Of course, it was a great database management system, which is very popular that might have a point of time. But again, it has a lot of limitations. It is a folder structure. Anything, if you want to update the child folder, we need to talk to the parent one first. So that's how this structure is being defined. However, this just a kind of a uh, pre-check before actually RDBMS. We are reaching to RDBMS. Before that, we are trying to understand what were the traditional things or what are the prerequisite of this RDBMS. So the first one is hierarchical, which is has a one-to-one relation. Okay, one-to-one relation, and this is basically structured in the form of tree structure. Okay, tree structure, and our Windows folder structure in our computer system. We see just as we have seen, it is the best example. That's how the hierarchical looks like. Let's move on to the next one, network. Network. Okay, let me give one more thing here. So when you're talking about folder structure, so how it starts with, that's what I just went to randomly. I went to something called a folder called drive called C. That's the parent one. Again, I went to some random folder called Windows. Under the Windows, I have subfolders. Again, I clicked on one folder. I went to. In that way, like we get tree structure. We are getting into one folder to get your proper information. Which file you want to get in? That's how you break it into pieces. But the hierarchy starts from the root node. That's what C drive is my root node. Then connecting to the child node, nothing but it's going to child one, that is the second folder. From there, you are going to second child, third child, fourth child, multiple children for a single parent. So it is kind of a tree structure, right? So to give a better example, let me just, I want you guys to understand how this hierarchical works. Very interesting, actually. If you talk about as a parent, okay, as a parent, let's take this is TV. Okay, let's take a simple example of TV. This is a parent node. Now I have something called, I have a two brands here basically, or multiple brands. I have one brand here, I have one brand here. One is called as Samsung. Okay, we have something second one called as maybe MI. Okay, in that again I have something called in that again we have something called, in the Samsung I have, in the Samsung again I have something else. Okay, in the MI I have something else. Maybe in the Samsung I have LED TV. We have one more thing called OLED TV. Okay, Full HD. We have multiple bifurcation again. In the MI, again, the same story. Like we have a different models. Better example to relate this to understand in a simple words, look at your organizational structure. It starts with CEO. After that, some people. After that, you have something called vice president. Under the vice president, let's take as a simple example as two AVPs. Under the AVP, again, a manager. Under AVP, two managers. Under two managers, there are multiple team leaders. Under team leaders, there are assistant managers to executives. Okay, how it flows from top to bottom, right? That is a simple structure, what we can say hierarchical model. Our group directory in companies called as a group directory, right? So that's what you create in basically in PPT. Like you want to tell who is your boss, under the boss who is assistant managers, under assistant manager who are the people working. So this is basically a hierarchy format. So if I want to talk at the lowest executive person, I need to come from the CEO to reach to this node. From parent to, if I want to reach to the child node, that's how I need to come, and it takes a lot of time to go to that person. So that's why a hierarchical model, I don't want to comment here. It's a good, bad, but that's how the structure works here. That's about the hierarchical model. Let's see what is the network. Hope you understood how the hierarchical model works. That is a parent and child, nothing but it stores in the form of tree structure. All right. So the next one is NDBMS, nothing but a network database management system. In this model, what happens is, again, it's a kind of one-to-one relations, or one-to-one relation. Primarily, that's how it is called as one-to-one relation, or it can have one-to-many connections or relationships. For example, as an individual, I can work in one company at the same time I'm working in other company, or else you can take example like this. I'm a lecturer for a university. I'm teaching in two departments. I'm teaching mathematics at the same time science. I don't know how it is possible, but that's how it works. Like a single lecturer who is trying to teach different subjects in two different departments, which is nowhere related. Like one is science, one is engineering, MBBS, whatever. So that means it works like one to one, just like the hierarchical. At the same time, it also works like one to many. Okay, one to many, or you can also say many to many. That means I am teaching mathematics at the same time I'm teaching science also. Okay, so it goes like one to many at the same time coming back to many to many or many to one. So, as I said, the best example would be I'm a lecturer. I'm teaching in a university in two different departments altogether. One science department, one is engineering department, and one is a MBBS department. I'm teaching at two different altogether subjects. So that how it works in a simple manner. But we need to uh, keep a note here, like this DBMS is the most widely used database management system because it has the capability of talking to one to many, at the same time many to many. So it is able to send the request as well as able to take the request. Most widely used network database management system. The next very important, not for us, because the last one is very important for us. ORDBMS, nothing but OODBMS, object oriented database management system. In this, what happens is basically whenever you are storing some information in the form of tables, as you've seen, hierarchical was only a tree structure, whereas sorry, in case of a network, it is storing with a different nodes, again one to one or one to many. But when you look at the ORDBMS, which is not really our part because it's out of scope, uh, we are just trying to understand one type how it works. Basically everything is considered as object in case of a object oriented databases. Everything, for that matter, everything is considered as a object oriented. So that's how it deals. As you guys are aware, like anything can be considered as an object. Your Excel application, your MS Word, your computer itself is an object. Myself an object. Yourself is an object. Whatever you see with your nick dice is an object, right? So object oriented programming language, object oriented database management system. So that means that any object oriented database management system, it will have the information or the data which is represented again in the form of object here, not in the form of tables. Of course, tables again is called as a object, right? As used in object programming, databases, such concept may have the complete controlling system. Okay, it is you might have this word buzzword oops. Okay, oops is nothing but object oriented programming. Okay, so it has a lot of security system which are really very tricky words, not really so clear. Something called encapsulation, inheritance, these kind of words are being used in object oriented database management system. If you're understanding, it's good. If you're not understanding, still it's good, because it's not relevant to our topic anyway. It is one type of DBMS what exists in this world. The very last one and very important what we require here, because we are talking about RDBMS. RDBMS is a database management system again, but here the best advantage what we have is we have we can start making relationships between one table to another. Okay, so let me go back to the traditional method again to understand it more specific. If I'm visiting to a bank, what they will do is they will, I'm trying to open an account. So obviously they need my details. I've given my name, my age, where I stay, what is my photo identity. I've given all the information. They opened the account for me. Then later on, I thought, let me also take a credit card. So I approached another department. They started recording all the information again for the same user, but this time it is for credit card. Again, he visited the bank because I'm rich, I want to take a loan. Again, they recorded in a separate book. So that means that single person information buying a different products from the same organization or the same branch or the same bank being recorded multiple times. I may not call this as a duplication, but just imagine how much space you're wasting in the records. In case of relational database management system, what happens is you will be identified with unique number whenever a record is being recorded in your table. Okay, uh, you have created your account, so you have your permanent number, bank account number, or any number. Okay, some identification number, social security number, other number, whatever. Next time when you're visiting, they will be identifying with that unique number. There's no extra line is being or extra table to be created within the same table. They can manage or all the credit card information in a separate table, all the loans related information separate table, all my anything other products which I'm trying to pick it up from the bank will have a separate table. So that means my data is still stored in a different tables because I'm buying a different products, but that can be easily pulled when I want to know how much this guy, what kind of different products I'm holding. With a single query, I can get all this information by connecting one table to another table because they got married to each other as a relationship. They are in completely relationship. They are being identified with the relations here. So how they are identified? Maybe with my unique ID, I don't know. Maybe with my social security. So every table will have some unique number, which will another table also will have. These unique numbers will talk to each other so that we can get the information just like that. To give a better example, let's assume we have a student. Okay, and we have a student name here, and we have rule number, let's say some ID, student name, we have a age. This is one table. And later on, I started storing all the information about the student date of birth. Okay, so if you look at these two typical tables, just for fun, just two typical tables. One table is talking about ID and student name, age. What if I want to ask a question to the first table? Can you please tell me what is the date of birth of this student? I don't have an answer. For that, I need to go for here. Okay, let me go to the second table. Can you please tell me date of birth of some person? Okay, that person name is not existing here. So this is a problem when you are trying to create a different tables. But what if you can maintain the relationship between these two tables? Now, this table and this table has a unique ID which is designated. Even if you're visiting to any supermarket, you'll be identified with some number, right? You have PAN number, we have Aadhaar number, we have voter ID. We are identified, social security number for that matter, credit card number, bank account number. It's all unique. I'm employee of a particular bank. I've been identified with some employee number, which can never be duplicated. That's it. This number will not be assigned to anyone. It will be given to only one person. So when I have this ID number, now my whatever the questions you are asking, I can simply answer it without any hesitation. You ask me, tell me what XYZ student name, his age, at the same time his date of birth. Simply, I can query two tables at once by using a different methodologies called joins or inner joins or you can use left join. Some types of joins you can use. You can use subqueries, nothing but query within the query. We can use it to get this so-called multiple tables connecting together and getting the proper. Now I'm in a position. Now I'm in a position by using this relational database management system. I'm able to answer any question you ask based on the tables what I have in my database. So that's a big thing what we have. So it's again a system, the way we are talking about a database management, which is organized in the two-dimensional again. Okay, two-dimensional again, I said one dimension is nothing but your row, one dimension is nothing but your column. And these tables are simply used by rows and columns only. There's nothing else. That's a tabular form, right? So this database management is the first system was introduced by this guy called Code. Okay, in 1970, actually, this very first guy who has just Code in 1970. So it was actually born and conceived in a year called 1970, this RDBMS. So from there, like we have relaxed. So we have all the relationship between the tables. We are able to save a lot of space in the data, in the servers. With a single query, we are able to get all the questions answered very in an easy way. So in the relation database, because data within the each table is identified with a unique number, so that's how we are able to make the relationship, and uniquely we are able to identify. So if you ask me what are the RDBMS databases, again the same answer. We have Microsoft Access from the lowest one because it's a desktop application. We have Microsoft SQL Server, we have Oracle database, we have MySQL, we have Portuguese SQL, we have SQLite. What else we have? We have IBM DB2. Okay, all these are considered to be a tables, relational database management system. So every table will try to uniquely identify with the table name, of course, because if you want to call me, you need to know my name. Okay, you are going to call me with a number. Okay, if I need to call you through a smartphone, I need to have your phone number, right? So that's how everything is being identified from unique number. So for now, let's understand unique means there's a lot of story to talk about. A key, okay, a unique key need to be have here, which is called as primary key. Let's not get into details because that's a big topic. Primary key and foreign key. So through which you are going to make relationship between the tables to make your life job easy. So that's how it works, the overall picture of your relational database management system. So